Hello and welcome to EduSathi. This is our last lecture on algebra and we'll be talking about sequence and series in this lecture. So let's start with arithmetic progressions first. Let me give you an example. Look at the series that I am writing 1, 3, 5, 7, 9, 11. Now if you look at it carefully, 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2 and 11 minus 9 is 2. That means every two terms, or I should say consecutive terms of this series, they have a common difference. Their difference is constant and is termed as constant difference. Or I could say is 1 plus 2 is 3, plus 2 5, plus 2 7, plus 2 9, plus 2 11. That means if I keep on adding a constant difference to the previous term, I would get the next term. So the terms would be represented as A, the first term, plus the constant difference that I am adding. I would get the next term. Again add the constant difference, A plus 2D, again add A plus 3D, again add A plus 4D. So I keep on adding a constant difference to the first term, I will get all the terms of this series. To find out any term of this series, I would use the formula which is A plus n minus 1 into d. That means the first term, and to the first term I will add n minus 1 times the common difference. So first term, second term I am adding once. For the third term, I am adding twice. For the fourth term, I am adding thrice and so on. So for the nth term, I will be adding n minus 1 times. If there are n terms only, so this nth term will also become the last term of the series. So I will be writing a plus n minus 1 d. The sum of n terms of AP are given as n by 2 into a plus n. So that means if I add up the first and the last term, multiply it with half of the number of terms, I will get the sum of all the terms. If last term is not given to me, I can always put back the formula and get my answer. So I'll put L is equal to A plus n minus 1 into D. This A will combine with this A and give me 2A plus n minus 1 D. The important thing to look here is, if you look at the first and the last term, the sum is 12. If you look at the second and the second last term, again 12. If you look at the third and the third last term, their sum is coming out to be constant. So, if there are n terms, you will get n by 2 groups whose sum is actually constant. And the sum of each group is equal to A plus n. This is what an AP looks like. So let's move ahead and let's talk about geometric progression. Again, let me give you an example. 1, 2, 4, 8, 16, 32, 64 and so on. Now look here. The difference between two consecutive terms is not constant, but the ratio of two consecutive terms is always constant. So I don't have a constant difference concept, but I have a concept of common ratio. If you look here, 1 into 2 is 2, 2 into 2 4, 4 into 2 8, into 2 16, into 2 32, into 2 64. So what do I have is, I have the concept of common ratio. So if I divide the two consecutive terms, their ratio would always be constant, and therefore the terms would be written as A into A, which is the first term, into R, the second term, into again R, the third term, into again R, the fourth term, into again R, the fifth term, and so on. So, important thing to note here is the concept of common ratio rather than common difference. And in general, nth term of a GP would be given by A into R raised to power n minus 1, because R will be multiplied n minus 1 times to the first term to give me the nth term. However, if I have to find out the sum of the terms, I will have to use the formula. The sum of n terms And the formula to be used will depend upon the value of r. That means whether the common ratio is greater than 1, that means it's a diverging GP, or the terms are getting higher, or the terms are getting larger. If it's r is 1, the further terms that you get are getting smaller than the original, or smaller than the first term. So the sum of n terms would be given by a into 1 minus r raised to power n over 1 minus r if r is less than 1, and it is given by a into r raised to power n minus 1 over r minus 1 if r is greater than 1. So depending upon the value of r, I would use the sum of the terms formula. To find out the sum of infinite terms, I would use the formula only if r is less than 1. Because if r is less than 1, the terms that you would get would keep on getting smaller and smaller, and the infinite number of terms that you will get would be actually close to 0. So the sum of infinite terms would be given as a over 1 minus r. However, if the terms are getting bigger and bigger, the terms that will come further would be very, very big for you to actually negate, to actually, you can say, to omit, and therefore the sum would turn out to be infinity. Let's look at some of the special series. These series I need to remember when I'm given a question on sequence and series. The sum of first and natural numbers. First means I'm starting from 1. The sum of first and natural numbers would be given by n into n plus 1 by 2. The sum of first n odd natural numbers. So this should start from 1, 3, 5 and so on. The sum of first n odd natural numbers would be given by n square. Here n is the count of first n odd natural numbers. Like first 10 odd natural numbers, first 20. So it's the count. The sum of first n even natural numbers would be given by n into n plus 1. So starting with 2, 4, 6, so on up to 2n, the sum would be given by n into n plus 1. This n here again represents the count of natural numbers. If you count the first 50 natural numbers, you will be starting from 2, 4, 6 and go till 100. The next thing that you need to look at is the sum of squares of first n natural numbers. 1 square, 2 square, 3 square and so on. This sum would be actually equal to n into n plus 1 into 2n plus 1 by 6. This is the formula that you need to remember. The next thing is sum of cubes of first n natural numbers. This formula is pretty simple. The sum of cubes would be given by square of the sum of first n natural numbers. So the sum of first n natural numbers is n into n plus 1 by 2. If I just square it up, that will be the answer for sum of cubes of first n natural numbers. And that will be given by, I'll just manipulate this sign, n square into n plus 1 whole square over 4. Another thing that I need to keep in mind when I'm solving a question in sequence and series is that whenever you have a cubic or quadratic series, you need to split it up. So summation a n cube, a being a constant will be out of summation sign, it will be a summation n cube. Plus b again constant will be out of summation sign, b summation n square, c summation n and d into n, because d will be added n times. So I just need to now apply the formula of summation n cube, summation n square, summation n, and then I'll get my answer. Let's look at some of the questions related to sequence and series. In a sequence of numbers above, each term after the first term is found out by dividing the previous term by a and subtracting b from the result. What is the result of b minus a? Now these kind of questions, you'll just have to look at the numbers that are there, try to find out the values of a and b from first set of numbers and try to apply it on the second and the third set to validate your answer. So if I just look at 48 and 20, how would I get 20 from 48? 48 needs to be divided with 2 to get 24, and if I subtract 4 from it, what do I get? I get 20. So as per this set, the value of a should be 2 and the value of b should be 4. I need to validate the same in the second group, which is what? 20 and 6. 20, if I divide it with 2, I get 10 minus 4 gives me 6. Perfectly all right. So that means the set of values that I have found from the first set is actually correct. 6 and minus 1. 6 divided by 2, which is 3, and if I do minus 4, I'll get a minus 1. So the value of B comes out to be 4, the value of A comes out to be 2, and your final answer that you need to mention here is 2. Let's look at the second example. In a sequence shown above, each term after the first is equal to the preceding term plus a constant k. So if you look at it, it is something like an AP that I'm talking about. A2 is A1 plus k. A3 is A2 plus k. I can write it as A1 plus 2k and so on. So it's a question that I have for AP. If the average or arithmetic mean of A2, A3 and A4 is 10, what is the average of A1 and A5? So what is given to you as, if you look at A2, A2 is A1 plus K. If you look at A3, it will be written as A1 plus 2K. If you look at A4, A4 is again A1 plus 3K. And I'm talking about average. Average means the number of observations over, sum of observations over number of observations. This is coming out to be 10. So this, I can just write, combine the numerator 3A1, 3 and 6K over 3 is equal to 10. I can just write A1 plus 2K is equal to 10. A1 plus 2K that I get is 10. So what is the question is? Find the average of A1 and A5. A1 is A1, A5 is A1 plus 4K. So average means I divided with 2. So again 2 A1 plus 4K divided by 2, it will be A1 plus 2K. And A1 plus 2K I already know it is equal to 10. So my answer is 10. We hope you have enjoyed this video. Please like our video and subscribe to our channel on YouTube. You can visit our website edusathi.com to practice more questions on this topic and access other useful information. Like us and follow us on Facebook and Twitter to get exam related information and other such updates. We wish you all the best for your preparations. Thank you and have a good day.